Okay, so we are going to run the analysis of our 2 by 3 factorial ANOVA using JASP. So I have JASP open and I want to open up my data set. So I'm going to go to the menu and open. For me right now it's on recent files because I've used it recently and I have it saved as the example analysis. But yours will be whatever you have your data set saved as on your computer. So here's my data set. Everything seems to be here. That's good. Okay. So first thing I want to do is make sure that my measures are being read correctly by JASP. So my dependent variable is not a categorical variable. It is a continuous variable. So I need to change that to scale. My hair and clothing independent variables are categorical, and hair is nominal. So that means that they are not related to each other in some sort of order. The two levels for hair were curly and straight. So they're not in any order, so that's fine. My 3 levels for clothing were professional, casual, and revealing. And there's no true order to that, so I need to change this from ordinal to nominal. And then I'm ready to run my analysis. So I'll go to the top and select ANOVA, and we're doing a classic ANOVA. And I need to move my variables to the correct box. So I want my dependent variable to go in the dependent variable box, and fixed factors is my independent variables. So I'll move those over, which were hair and clothing. My results are coming up on the right, but I also want to get the descriptive statistics and the effect size. So let's go ahead and look at the results for our Omnibus test. Remember that Omnibus means overall, and so this is the overall test measuring whether the means of the levels were different from one another. So each of these rows represents each of our tests that we ran. So this first row is the main effect of hair, the second row is the main effect of clothing, and the third row is the interaction effect. So this is my first hypothesis, my second hypothesis, and my third hypothesis. Going across the columns, I have sum of squares, degrees of freedom, mean square, the F statistic, the p-value, which tells me the significance, and the effect size, which is an eta squared. So first thing I do want to look at is the p-value. So remember that less than 0.05 for this test means that it was significant. And so each of these are less than 0.05, so that's great. That means all 3 of my tests were significant. However, an omnibus test, this ANOVA test here, does not tell me where the differences are. So for example, with clothing, I know that there is a difference between professional, casual, and revealing. I just don't know where those differences are. So I'll need to probe further by running a post hoc analysis and looking at the marginal means. And so we'll do that in just a moment in the next video. But this, for now, tells us that there is a difference and that I need to probe further. We'll look at the descriptives. So these are the cell means. These are the means that we use to make our interaction figure. And the way that we read this is kind of separating them into columns. So we have hair and clothing. And so I can bring the codebook into the screen. So here's my codebook. Curly hair was coded as 1 and straight hair was coded as 2. So this is curly hair and straight hair. And clothing was 1 was professional, 2 was casual, and 3 was revealing. So this is curly hair with professional clothing, curly hair with casual clothing, and curly hair with revealing clothing. So these means attached to it are the mean for that vignette. So remember I had 6 vignettes. So Three vignettes all had curly hair, three vignettes had straight hair, and they're attached here to which clothing the tutor was wearing. So, for example, this mean of 4.94 was the mean rating of dependability for the tutor with curly hair wearing professional clothing. Just looking at it, I can see that there are some differences here, especially right here. There's a big difference. So what is this? This is curly hair with revealing clothing. And the dependability rating on average was 2.2. And so I can see that my range for my dependent variable was from 1 to 6, with 1 being low and 6 being high. So this is telling me that there was a very low rating of dependability if the tutor had curly hair and was wearing revealing clothing. If they had straight hair and were wearing revealing clothing, they had an average dependability rating of 4.68. So that tells me that revealing clothing isn't really important when we're considering the dependability of a candidate. Surprisingly, more importantly, it's all about the hairstyle. So the curly hair is really driving this effect to lower ratings of dependability. So we've run our Omnibus test, and now we are going to probe to find out where the differences were with hair, although we can pretty much see that it's probably going to be that curly hair was lower in dependability. We'll see where the differences were with clothing, and we'll see what our interaction effect looks like.